Hello, algebra students. Welcome to Mr. Chao time. Here we are, Unit 1, Expressions and Equations. The first lesson will be variables and expressions. So, let's start with some vocabulary. These vocabulary words are on page 5 of your textbook, if you wish to follow along. Number 1. They're not really numbered. The first one, algebraic expressions. This is a math sentence with numbers or variables. So, for example, sorry, had to turn on my pen thingy. Something with numbers or variables and at least one operation. So for example, 2x plus 3. This is a expression because it contains a number or a variable. It doesn't have to have both 2 plus 3. This is also an expression. Or x plus y. You don't have to have numbers. You don't have to have variables, but you need to have something in there and some sort of an operation. A variable, this is a symbol used to represent a value, like x or y. A term is part of an expression that is like a number or variable or a combination. It can be a combination, for example, 2x plus 3. 2x is a term, 3 is a term. So it could be a number and a variable as long as it's combined. It needs to be combined as a product or as a quotient. So for example, x over 2 plus 3. X over 2 is also a term. 3 is also a term. Factors are quantities being multiplied, like 2x or 2 times 3. The product is the result of multiplication, so 6 here is the product. Power, exponent, and base, I should just do all these together. So if we have x squared, then this is a term with an exponent, so this is a power. The exponent is this right here. The base is this number here. So the exponent is the number of times that a base is going to be multiplied by itself. So this you can think of as x times x. That is x squared. You're multiplying x by itself 2 times. So the exponent is 2. The base, the thing that you're multiplying, is x. All right, so these vocabulary words, they aid us in writing verbal expressions. So let's do that. Oops. 2x squared. This is a term with an exponent. This is a variable, and 2 is being multiplied by x squared, so that means these are factors, and this is going to equal a product. So knowing all these things, we can write a verbal expression. A verbal expression is putting this into words. So you can say that this is 2 times, times x to the power of 2. You could also say that this is 3 times z to the power of 3 plus 4. So now we've written verbal expressions from these algebraic expressions with the help of our vocabulary words. Moving on. We can do it backwards. In other words, a verbal expression can also be translated back into algebraic expressions. Here are some examples of operations. I'm sure you know these already. Here are some verbal phrases that oftentimes are associated with these. So, when you're talking about more than or sum or plus, oftentimes it's addition. Less than is oftentimes subtraction, so on and so forth. I'll let you read this. You can pause this and take a look if you need to. So let's practice this. A number t more than 6. You could also write 6 plus t. 10 less than the product of 7 and f. The 7f, 10 less than that. 2/3 of the volume v. 2/3 of the volume v. I will take this opportunity to quickly talk about multiplication. You may have learned to use x to multiply 2 times 3. We try not to do this anymore in the higher levels of math as you get higher and higher, because x often looks like the variable x, right? So if you're writing 2x times 3, then it can kind of get confusing, and sometimes you might mix them up. So we try not to use this x anymore. And you may have learned to use a dot to signify multiplication. So you might have learned you can say 2 times 3. And I'm going to tell you not to do that either, because this dot can oftentimes look like a decimal. So is this 2.3 or is it 2 times 3? Well, it's pretty obvious in these examples, but when you're writing fast, it might not be so clear. These are all times, but this one kind of looks like it could be a decimal, right? And this one honestly does too. This is the only one that doesn't look like a decimal. So when you're multiplying a number and a variable, you can just put them together like this. But when you're multiplying two numbers, I suggest that you use parentheses. So 6 times 3. This will always mean times. It's going to be hard to mistake that for anything else. And this is what I suggest you use. And on the computer, you might also see this thing. I guess you could do that if you wanted to. I just think it's easier to do this. 6 times 3. You don't have to put the 3 into parentheses. This is pretty clear. You could also do this or some combination of this. All right. Variables can represent quantities that are known or unknown. So a variable, again, is something like an x, where you don't know what that is. Sometimes you might get a question and it tells you that x is the number of players, and then they'll tell you that x equals 5, and that happens. Sometimes they don't tell you what x is, and you have to solve for x. They are also used in formulas, expressions, and equations. So let's take a look at an example. Mr. Su orders 250 keychains printed with the KAS Teams logo and 500 pencils printed with the KAS web address. You're being asked here to write an algebraic expression that represents the cost of the order. So, how are you going to find out how much this costs? Well, 250 keychains printed with KS team logo, 500 pencils, right? And we don't know how much these things are going to cost, and there's no indication that they cost the same thing, so you can't multiply by the same variable. You can say that, let's say K is the cost of keychains, and you can say that P is the cost of pencils. So 250 K plus 500. I should just, there we go. 500 P. This represents the total cost of this order. So that's it for episode 1. Hope you enjoyed. See you in class.